7.3, logarithms and logarithmic functions. Okay, last class we learned about how to graph exponential functions or exponential functions like these, right? So they kind of grow like, for the most part, they go up like this. Now we're going to talk about the inverse of those things. And remember how we do the inverse? We flip it across this y equals x line here. Right, flip it across that line. And when you graph it, looks like this. Right, so as they bring up here, if you have y equals 2x, the inverse, if you remember how we find inverse, we just switch x and y, would be x equals 2y. Now that is kind of funky. So what we do instead is we use this what we call a logarithm function to rewrite that as log base 2 of x equals y. And that's what we like to see it. And that's what this lesson is about, is how to deal with logarithm functions. So with logarithm function, it's just the inverse of an exponential function. That's all it is. Okay, so let's talk about how to write it. So in general, we have log base b of x equals y. That's how we're going to say it. This is log base. So that's the base. Now usually it's written small. My bad writing right there, you can't really see it. You can see stuff like this. Right, so that's the base right there. Base b of x equals y. So log base b of x equals y. So that's how you say logarithm function. Now let's talk about how to go from one to the other. How do we go from an exponential function like this to a log function like this, or vice versa? Okay, well the key thing here is this, right? This is log base b. That's our base. Well, that's the exact same base here. So if you want to go from one to the other, it's all about finding the base. So here's my base, and then we're going to say, and then so what we do next to go, if we want to go that direction, we're going to find the base, take it to the answer equals the power. So we're going to get b to the answer equals power. And that's how we write it. So let's try it. So let's look at one right here. So first thing we do is find the base right there. So we're going to get 4 to the answer, so 4 squared equals 16. Right, and does that make sense? 4 squared does equal 16. So that's how we write it. It's all about finding the base. Base to the answer equals the big number. So over here, 1b, right? Again, let's find the base, 3. So 3 to the 6 equals 729. And you can double check that is true. So you get something like that. Let's go on to these other two right here. Right? 8's the base, 8 to the third equals 512. And finally right here, find the base, log base 5 of 62 equals 4. So 5 to the fourth equals 625. So that's how you go from log to exponential. So next step, naturally, is to go the opposite way. Let's go from exponential to log. So now this time we're going to have the base, so it's going to be something like this. I want you to write as a log. Well, it's the same concept. Find the base. The base is the same for both of them. So you find the base. Base to the answer equals the power. So log base b to the y of y equals x. The exact same concept. Find the base upon this one. Here's my base. So I'm going to write log base 4, so it's a little smaller, to the 64 equals 3. So that's how you write it in log form. It's just find the base, base to the answer equals exponential. So base to the answer equals exponential. So same thing here. Find my base, which is 125. Log base 125 of 5 equals 1/3. And finally one right here, right? 11 is my base. So log base 11 of 1331 equals 3. Right, so if you notice, well, the whole idea of a log is this. It's basically saying, hey, 11 to what power equals 1331, which in this case is 3. 4 to what power equals 64? 3. That's all a log is. Again, it's just a reverse, it's an inverse of an exponential function. So you're just trying to figure out, how do I get 4 to what power gets me this number here. And that's kind of how we're going to do the next part of this, is how do we simplify this stuff without a calculator? So how do we figure out what logs are without a calculator? Well, there's two ways to do this. I'm going to show you way one first, which is by definition. So what do I mean by that? This is kind of like what I said. If you see this, you want to think 3 to what power is 81. So if you look at this, you just go, okay, this is telling me 3 to what power is 81. So you just got to think 3 to what power is 81, and that is 3 to the 4th. So my answer is going to be 4. Because 3 to the 4th equals 81. Right? That's how you do it. That's one way to do it, at least. And that's by definition. So if you know your powers, you're like, okay, 3 to what power equals 81, you're done. What if you don't know your powers? Well, there's no way of going around this. You got to know your powers. But an alternate way, I actually did when I was in high school, was I would set equal to x. So I would get this. Log 381 equals x. And then what I do is I rewrite it. So like we just talked about, you find the base. Base to this equals this. So you get 3 to the x equals 81. Now it's essentially the same question. You're saying 3 to what power equals 81. Now, this is how we did on the last night's homework, where you just got to go try to rewrite this, and you try to say basically the same thing. 81 is 3 to what power, and you figure out it's 3 to the 4th. So once you get the same bases, if you remember, what we do then is drop the bases. You get x equals 4. So either way you get 4, right? And they're honestly kind of asking the same question. It's just the way you approach it. Do you feel better setting equal to x and then rewriting it? And a little more like last time, the homework we had last time? Or do you prefer just to think about it going, hey, 3 to what power equals 81? So it doesn't matter. Let's look at 3b here. Again, same idea. You could go 1/2 to what power is 256. Now it's kind of tough. First you got to think, well, 1/2 and 256 don't match. Like this is a fraction, that's not a fraction. So they negate it. How do you flip it? They negate it. And then 2 to what power equals 56? And that would be 8. So this is actually -8. Again, why negative? Well, I start off with 1/2. I got to get 256. Alright, only way you can get a power to go from a fraction to not a fraction is to negate it. So that makes it flip. So it's just be -8. Again, way 1. Alright, way 1's good if you know your stuff. Way 2 is a little gives you structure. Right, way 2 is set equal to x. Set equal to x, rewrite it. So find your base, 1/2. 1/2 to the x equals 256. Now it's just like last time's homework. We gotta try to get the bases to match. So lots of ways you can do this. First, you gotta break down 256. No matter what you do, you gotta know that 2 to the 8th is 256. So this is gonna be 1/2 x equals 2 to the 8th. Now the bases still don't match. Remember the way we fix that is we flip this. You gotta flip it if you want them to match. So that's gonna be 1/2 x equals 1/2 -8. And then since these match, the bases match, you have x equals -8. So again, no matter which way you do it, it kind of turns out to be the same thing. You always gotta know your powers, and you gotta know, in this case, you gotta know that you have to flip it. There's no shortcut to that, sorry. These next set, right? Still more of the same. How do you simplify this? You could go 4 to what power? In your head, you do this. Is 1/64. Same kind of idea, right? First thing, 4 to what power equals 64? That would be 3, right? 4 to the 3rd equals 64. But I got to flip it, so that makes it a -3, because the negative power flips. If you don't like that, do the more mathematical way. Just set it equal to x. Rewrite it, find the base to that, equals this. Try to get the bases to match, so I would say this is 4x is equal to 1/4 to the 3rd. Then you got to flip it, 4x equals 4 to the -3rd. So these match. again, no matter what you do, you're going to have to know your powers. You're going to have to flip just the way it is. Let's go to this last one here. So again, you go 1/8 to what power is 512. And just like before, it's a fraction, so I gotta flip it, so it's be negative no matter what my answer is. And then 8 to what power equals 512, that is -3. So that's always way one. Way one's just looking at it and understand what it's asking. It's asking this to what power equals that, and then trying to figure it out. Way two is a little more mathematical, right? Way two just says set equal to x and rewrite it. So you find the base to the answer equals 512. But then it kind of goes down to the same question. You're like, okay, well, this is an 8. Let me rewrite that as an 8, and that's 8 to the third. Then you're like, well, these all match now, so I got to flip this. So 1/8 to the -3rd, and that would be my answer. X equals -3, just like we got. So again, two ways to do it. They're essentially the same things, just how do you see it? Do you like setting equal to x, which I used to do in high school, honestly. That's the way I used to do it. Or I like to do the way I do now, which is just kind of think about it. 4 to what power is 61/64. Either way, you gotta know your powers. Okay, so we're going to talk about how to graph logarithm functions. So here's two types of log graphs, and honestly, I don't care about this one. This is a decay log graph where your b is less than 1, so it's decaying, but nothing I care about. This is the money one. We care about the basic log graph where b is greater than 1. That's the one we're going to deal with the most. And that graph, again, it's just added to the list of graphs we know how to do. So now we should know how to do a basic log graph, which what happens is it starts out at 1 here. That's where it starts, and then it goes up like this, and then kind of goes up slowly. It can never cross this line. You can't have negative logs. We'll talk about that more later. So you can never have a negative log unless you move it afterwards. So that's a basic log graph. Goes up, crosses that one, and then continues growing at a slower rate. So it doesn't matter what the base is. The basis changes. The base just changes like how wide it is. You can see right here, 1/the base is equal to -1. That's a little too much detail. All I care is you understand the basic graph of this. So it looks like this. It's going to cross at 1. If you really want, it's going to be 1/2 and -1. And then it goes up and it grows slowly. Again, this is the what am I going to say? This is the decay graph, but I really don't care about that one. I care about the basic one. Okay, so now it looks like, now that we know the basic one, right? Because I don't really care about that one. Now that we know the basic one, let's talk about how to move it like we always do, right? I'm going to move up, down, left, right. Let's do the transformations. Right, so as always, here's our basic graph. Right, and then hopefully as we know by now, anything on the inside, like I like to say, inside x opposite, right? Again, anytime I say that, what I mean is, here's your x, here's your y. Anything on the inside of the function, move your graph left and right along the x-axis, hence inside x. Opposite, because you do the opposite, right? If it's a -h, that means +h, so you move it right 3. If you see a +3, you move it left 3, -3. So that's inside x opposite. The outside affects the y value, right? Oof. I'm slightly better. Outside is the y value. So on the outside, it moves it up and down along the y-axis, hence outside y. And then I say follow because you follow what it says. If it's a positive, you go up, negative, you go down, right? There's no switching involved. So once you know your basic log graph, which we should know looks like this, right? Crosses that 1. Remember, it's just the inverse of an exponential graph. That's why we have a vertical asymptote instead of a horizontal one. That's why we cross at 0, 1 instead of 1, 0. So once you know your basic graph, you just move up, down, left, right. What are the fancy transformations? Well, as always, what happens if it's a negative? What if it's like a -a log bx? Well, as always, that's a vertical flip. It's on the outside, also known as a reflect across the x-axis. So you have something like this. It normally looks like this. But if it's a negative, it's going to flip down. So look at that graph I don't care about. But I care about it now because it's just a flip of the normal graph. And then, as always, remember, if your A, the number in front of it, A here, if that A is greater than 1, it's a vertical stretch. That's me underlining it, not crossing it out. That's a vertical stretch, so it's going to grow bigger. So we get like it double the size compared to the normal one. And if A is less than 1 but greater than 0, then it's compressed, right? So it's smaller. So normal graph looks like this. Our graph is like 1/2 of it would be half as small, right? So same rules that we always do, right? Number outside makes it bigger, smaller. You move it up, down, left, right. So let's look at a few of these. So this one here, it's my straight line because I can't draw a straight line for the life of me. Right, let's talk about what a basic graph looks like, right? A basic log graph looks like this. Not like that, like, oh, something to that effect crosses at 1. Right, that's what a basic log graph looks like. Now let's look what this graph's telling us to do. Right, inside x opposite. So we're going to move it right 2. So instead of being at 1 here, we're going to cross at 3. Also keep in mind, normally you have a vertical asymptote right here at 0. This is always going to be a vertical asymptote. So vertical asymptote will now be at 2. Because it's always, it was at 0, now you moved it over 2. Other than that, it's a normal graph. With a little bit of vertical stretch. I didn't really draw it, but that's the idea. Right, so know your basic graph. 0 and that crosses at 1. That's the basic graph. Now what we're going to do is move the whole thing over 2. So it goes from 0 to 2, it goes from 1 to 3. And then you draw a normal graph. Let's try that again. Lines are not getting better. Okay, so again, another log graph. Let's talk about a basic one, right? Again, the 4 part really doesn't matter. It affects the stretch and shrink a little bit, but not, unless you have a calculator, we don't really care. So a basic graph looks kind of like this. And again, it's just a sketch. That's all we care about. That's 1, asymptotes at 0. Now what we do in this graph is that we're going to move it right 6. Right, so first thing, your vertical asymptote is going to be at 0 now. At 6 now, sorry. So let's say this is 6. Right, I'm moving it right 6. So this is my vertical asymptote. And then that's 1 to the right, so that went over 6. That's going to be at 7. That's what we're crossing. Other than that, it's a log graph. It's a pretty big vertical stretch. So if I was trying to multiply the normal graph by 4, so to get like 4 higher. So it kind of looks like this. But again, that's always extra credit. The thing I care more about is how you move it. So I guess something to that effect. Okay, let's move on to the last problem. Again, these are the DK ones, so we're still not going to bother with those. Let's go on to this one. Right, so this one, again, it's a normal log graph. Actually, let's make it a little more interesting. Let's go like +2. Let's have some fun with this. Hey, kind of straight line. Hey, I'm impressed. Okay, so we're going to do log graph. So let's talk about what a basic log graph looks. Right, so again, asymptote at 0, you're going to cross at 1. So that's what a basic log graph looks like. Right, and then we're going to do all this stuff to it. Again, notice how it's a negative out there, so I already know my graph's going to be flipped. It's looking more like this now. Because the negative on side is going to be a vertical flip. So when I actually do graphs, it's going to go down. So again, right now we're kind of right there. Look what we have to do. We have to move right 4. So we're at 1, so we're going to go all the way to 5. Then we're going to move up 2. So that point right there, that was 0, 1 when we start off usually, it's going to be to move right 5 and up 2. It's going to be like right there. At 5, 2. Let's not forget our asymptote, right? Our asymptote was at 0. But now I moved to the right 4. So 1, 2, 3, 4. That's our new asymptote. Other than that, that's our graph. Now, don't forget, we flipped it. So we actually got to flip it here. So it's going to look like, kind of like this. Something to that effect. Ooh, I almost forgot the 8. So it's actually a very big stretch. If I was doing correctly, it should have been way more like, because it should be multiplied by 8. So it should be really big. But that's the general idea, right? Negative flips it. Don't start with your normal graph. So asymptote's at 0, crosses at 1. Now we move it right 4 and up 2. and that's it.